Hello, and today we are going to learn how to rewrite logs and exponentials as each other. This is going to help us when we're trying to solve later. So first of all, we want to recall that exponentials and logarithms are inverses of each other. You can see that we have it in very simple form here. Base raised to a power is equal to an answer, and then in a log equation, it's log with a base of b of the answer is equal to power. So notice how the power and the answer switch, because when you take the inverse of something, your independent variable and your dependent variable switch. And this also satisfies the idea that a log really expression is equal to an exponent that you would raise your base to in order to get to your answer. Okay, so let's take a look at a couple examples we would want to rewrite. For this example right here, log base 2 of x is equal to 5. The x is on the inside of the log function, so if we were trying to solve it and we wanted to get the x outside and switch it with this 5, that would be taking an inverse. We need to use the inverse operation or rewrite it as this inverse equation. So the base of the log is 2, so the base of the exponential is going to be 2 as well. And then remember that your independent and dependent variables switch, so this is 2 to the 5th is equal to x. And consequently, we have actually ended up solving this as well, which is good. Let's look at an example that starts off in exponential form. So in this case, the x is in the exponent, which is in the independent variable. If we were trying to solve it, we would want to rewrite this with the x not stuck inside of the function. So if we wanted to take this exponential and rewrite it as a log, we would be able to isolate the x more easily. So base of the exponential is 7, so the base of the log is going to be 7 as well. The power and the answer switch, so it's going to be log base 7 of 3 is equal to 2x. And you can see how this is only one step away from being solved for x, which is what we're going to study a different time. Okay, here we have an exponential that if we wanted to isolate x, again, we need to rewrite it as a log, but there's other things happening to it. So just to clarify, whenever you want to rewrite an exponential as a log, you need to have it in the form of base raised to a power is equal to an answer. In this case, we have other things in the left side expression. In order to rewrite this, we would need to isolate the 10 to the x power, which is the base and the power. So to do that, let's add 3 to both sides to start with. So we'd have 3 times 10 raised to the x power is equal to 8. Also, I want to point out here that you cannot multiply 3 and 10 and then raise it to the x power, because if you use your order of operations, you would always have to raise to a power before you multiply. So we are not able to multiply these and raise it to the x. That is a no-no. We would have to raise 10 to the x power and then multiply it by 3. Because we don't know what this power is, we cannot multiply by 3. Alright, but we can get rid of the 3. If we divide both sides by 3, that would get rid of that 3. So we have 10 to the x is equal to 8/3. Okay, now we have it in the form of base raised to a power is equal to our answer. Our answer is a fraction, but it does not matter. Let's rewrite this as a log so that we can get that x out of the exponent. All right, log with the base of 10 is just the common log, so we can write that like this. Log of remember the power and the answer switch places, so this is going to be common log of 8/3 is equal to x. And again, this is already solved for x, which is nice. Alrighty, now let's look at an example that looks like this. This is a little bit trickier than others. Once again, we need the log in the form of log with a base of something is equal to something else in order to rewrite it. Currently, we have other things happening here with this log, so let's get rid of that extra stuff. Let's start by subtracting 3 from both sides. So 2 times the natural log of x plus 5 squared is equal to 8. And then let's divide out that 2, because again, we can't do anything until we get rid of all this coefficients. So natural log of x plus 5 squared is equal to 4. Okay. All right, now this is a natural log, which means its base is e. So if we're going to rewrite this as an exponential, we need to write the base of our exponential is e. And remember that your answer and your power switch, so this is e to the 4th is equal to x plus 5 quantity squared. And again, if you were going to solve this, you can start to, because now you have a quadratic equal to, this is really a constant, and you can certainly solve this. So that is the benefit of rewriting a log as an exponential and vice versa. It's really so that you can get your independent variable outside of whatever the function is, so that you can then solve algebraically. And there you have it.